So for absolute value equations, there really isn't a whole lot to worry about for this. You just need to make sure that you remember what our expectations are for an absolute value equation. For the most part, we kind of expect to get two answers from this. So here are a couple of statements for us. If the absolute value of an expression is equal to another expression, then what we conclude from this is that A has to equal B, or the expression inside that A has to equal the opposite, negative B. Okay? Well, if you have questions about stuff going on the rest of the semester, you can always email me. I will be sending out an email maybe later today or tomorrow about more solid plans about what's going on. Okay? The other statement that we have here when it comes to absolute value equations is if the absolute value of A equals the absolute value of B, then the way that this equation is going to be true is if those expressions inside are the same or if they are opposites of each other, like this. Okay? Now, we've already seen these guys, we've already worked through them, so this is really a review. So remember what it looks like to have something like this. If I say solve the equation, the absolute value of x equals 9. Okay? If the absolute value of x equals 9, there's two things that can happen here, right? Think about what has to be inside this absolute value. In order for the absolute value to equal 9, the number inside has to equal 9 or it has to equal negative 9. And that's what this first statement is saying right here. So the conclusion is that the expression inside has to equal 9 or the expression has to equal negative 9. And you may be saying, well, how is that possible? How does that work? Well, if you go off to the side here and you just take a moment to check. Okay? If I plug in 9, you see that the absolute value of 9 equals 9. Also, when you plug in negative 9, the absolute value of negative 9 equals 9. Okay? Remember that the absolute value doesn't change the sign. The absolute value strips away the sign until you have just a positive value left over. So the absolute value of a negative number is going to be positive, and the absolute value of a positive is also going to be positive. One of the big things that we said in class before about absolute value is that it measures the distance from 0. So if I look at this on a number line, and here's 0, and I'm asking you to find the values of x who have a distance from 0 of 9 units. Well, if I go over here 9 units, 9 is naturally 9 units away from 0. If I go to the left 9 units, and I'm at negative 9, and this guy is also 9 units away from 0. So both of those guys are solutions. I don't care that this is a negative. I care that it's 9 units away on that side. Okay? One of the big things that's going to help us in solving these equations is making sure that we isolate the absolute value before we do anything. Okay? So these absolute value equations tend to leave us with two solutions. I'm not saying that it always works that way, because we're going to see some examples where it doesn't work that way. But for the most part, we expect to get two solutions. So if I want you to solve the absolute value of x minus 4 minus 7 equals 11. You need to understand that although the absolute values act as grouping symbols, you can't just ignore them, because they do form a group. They form this little barrier around the expression x minus 4, but they also have that added piece about being absolute value. And absolute values cannot be applied to individual pieces inside of it. Okay? It's applied to that whole group. So when we solve these equations, we have to first get the absolute value by itself. So, just like normal, add 7 to both sides. So we get the absolute value of x minus 4 is equal to 18. Notice that I still have the absolute values here in this problem. They don't go away just yet. All you did was add 7, and you moved it to the other side of the equation. Now that the absolute value is by itself, you set up your two equations that you need to solve. And it's here where you stop writing the absolute value. So what we're saying is that the absolute value equals 18. And the only way for the expression inside to give us 18 once we apply the absolute value is if the expression equals 18 straight up, or if the expression inside is equal to the opposite of 18. So if this expression inside equals 18, then the absolute value of 18 is 18. Also, if the expression inside the absolute value equals negative 18, once you apply the absolute values on it, it's going to return positive 18 as a result. So these are the two possibilities that we have, and we just solve these equations like so. And this is where we go back to feeling happy about our life choices, because things are nice and linear like that. So for one part, we get x equals 22, and then over here, x is equal to negative 14. It doesn't take long to plug those guys back into the original equation and see that they do both work out. All right? Not too bad, right? Again, the key is to isolate the absolute value, and then you're going to separate into your two different equations. And of course, you know what I have to do. I just have to keep adding more and more things to this because that's how we have fun. So the absolute value of 3x minus 10 plus 2 equals 20. So before we can really do anything, we have to make sure that we address the issue of getting the absolute value by itself. Okay? So, subtract 2 on both sides. So we get the absolute value of 3x minus 10 is equal to 18. All right. Again, understand that you can't move things out of this absolute value. You now have to recognize that the absolute value is by itself, and you separate into your two equations. One of those is where the expression inside is going to equal 18. The other possibility is where the expression inside doesn't equal 18, but it equals the opposite, negative 18. So you're going to go through the process of solving each of these linear equations, right? And you'll notice, as we mentioned earlier this semester, that the steps you take to solve one are the same steps that you're going to take to solve the other one. So we add 10 to both sides, divide both sides by 3, so x is equal to 28 thirds. Okay, that's all we can do for that. Over here, notice that the steps are the same. I still have to add 10 to both sides. So 3x is equal to negative 8. Why do I feel like I've done something wrong? Something doesn't seem right. And divide both sides by 3. So x is equal to negative 8 thirds. Okay? And there we have it. Right? So you separate into your two equations, and everything is fine. Again, a lot of the mistakes that I've seen with grading exams and quizzes is when people don't get the absolute value by itself first, or they try to move things outside of the absolute value But no, get the absolute value by itself, then you separate into your two equations. You do that, and you're going to be fine. Alright, so let's do 9 minus 4 times the absolute value of 2x plus 7 equals negative 11. Alright, so the big picture here is an absolute value equation, and you need to get the absolute value by itself. Okay, so start peeling away those layers until you get the absolute value by itself. So, first a warning, do not subtract 9 minus 4. This 4 is connected to the absolute value through multiplication, a pretty strong connection there. So move the 9 first. So subtract 9 from both sides. You still have negative 4 times the absolute value of 2x plus 7 equals negative 20. Now, we are not quite ready to separate into our two equations because I have not gotten the absolute value by itself. Not until I divide both sides by negative 4. Okay? So now, we have the absolute value of 2x plus 7 is equal to 5. And now that you have the absolute value by itself, this is where you separate into your two equations. So we have 2x plus 7 equals 5, or the other possibility that we can have is that the expression inside is equal to the opposite, negative 5. So you go from this absolute value equation into two linear equations that we can hopefully quite easily solve. Right? So subtract 7, that's the first step for each of these. Alright, so 2x is equal to negative 2 over here, and 2x equals negative 12 over there. Divide both sides by 2 to finish getting x by itself, and that's the same step we have to take for the other side. So x equals negative 1, or x equals negative 6. And that's it. And I feel like almost all of these absolute value equations are just that easy. You just have to make sure that you get the absolute value by itself first, and then you separate to your two equations. Notice that the 2x plus 7 stays exactly the same. It's what's on the other side that changes the sign. Even in the last problem, this 3x minus 10 is the 3x minus 10. It stays the same for both of these equations. One equals 18, the other one equals negative 18. That's how you form your two equations. That's all we have to do. Sometimes, though, we get tricked a little bit. So you have to make sure that you are paying very close attention to the situation. If I do this and I say solve the equation, the absolute value of x plus 4 equals negative 7. Well, you want to get the absolute value by itself first. So we would subtract 4 on both sides. Alright, so the absolute value of x is equal to negative 11. So now we have a problem. And it really goes back to something I should have said on the first page. So these statements are going to be true provided that that constant on the other side is a value that is not negative. Because see, when it's negative, like this guy, now we have an issue. Because absolute values can't give you negatives. And think about the graph of this. We just got done, just before spring break, we were talking about what these graphs look like. Okay, we talked about what does the absolute value of x look like. And it is this V shape like this. Okay? If I look at negative 11, that is a horizontal line right here. And so if you're trying to figure out where will negative 11 and the absolute value of x intersect, well, they don't. And so we end up here with something that is no solution. Okay, so you got to watch out for that. The absolute value is never going to give you a negative number, no matter what you do. Okay. So now that we have that weird guy out of the way, take a look at 4x plus 11 in absolute value is equal to the absolute value of 2x minus 13. So one of the other statements that we made about these absolute value equations is that when you have two absolute values equal to each other, you break this down into your two equations. One, if the absolute values are equal, that means that the expressions inside must either be the same, or the other possibility is that one expression, let's say 4x plus 11, is equal to the opposite of the expression inside the other absolute value. So make sure that you put that in parentheses with the negative, because that negative has to distribute if we were actually doing the opposite. Over here, it's just going to be an equation to solve. You know what to do. Subtract 2x on both sides. And then we can subtract 11 to move the constant to the right. And so now we have 2x is equal to negative 24. Divide by 2, and x equals 12. So that guy is golden. On the right side, or the right half of the equation, excuse me, not the right half, but the other equation that we have, go ahead and distribute that negative. So negative 2x plus 13, and it's just a normal linear equation. Let's add 2x to move it to the left side. So that guy's gone. Moving the variables to the left, the constants go to the right by subtracting 11. Right, so that guy's gone. We now have 6x is equal to 2. Divide both sides by 6, because remember you were dividing by that coefficient. X is equal to 1/3. Make sure that you do reduce your fractions all the way, and everybody's going to be happy. Okay, so there you go. All right, I've got one more equation for us to solve because it's super fun. And I've already done the first step for you. It's the absolute value of x squared plus 10x equals 11. So in this problem, the absolute value is already by itself. So what we need to do is we need to separate it into our two equations. So one of these equations will be x squared plus 10x equals 11. And then the other possibility is going to be x squared plus 10x equals -11. Okay, so first things first. we recognize that we have quadratic equations. We actually have two quadratic equations, which means I should get two solutions from here and two solutions from here. Kind of crazy, but yeah, it's going to work. We're going to have a total of 4 solutions. Now, I see that I've got 2 instances of x with my terms, so I cannot use the square root property. Maybe I should try to factor. So to see if this is going to factor, I need to move the 11 over here to the left. And let's see, can we find factors of 11, in this case, that will subtract to 10? And I think without a lot of work, we can see that we're going to factor this as x plus 11 times x minus 1. Okay? And then from here, x is equal to negative 11, or from that factor, x equals positive 1. All right, so there are 2 solutions out of the possible 4 that we mentioned at the beginning. Now let's see about this guy. If I move the 11 over, I would get a plus 11. And are there factors of 11 that add to 10? I think about 11, it only has 2 factors, 1 and 11. 1 and 11 don't add to 10, so if I move it over, it's not going to do anything positive for me. But let's go through our progression for solving quadratic equations. If it doesn't factor, and we can't use the square root property, the next thing we try is to use completing the square. Okay, so to complete the square, let's go ahead and create our gap like this. This guy is a 1, which is great. This is even, which is fantastic for completing the square. So we know that we can complete the square without causing a big headache. So half of 10 is 5. 5 squared is 25. So that's what we add to both sides of the equation to complete the square. Just like that. All right. So on the right side we get 14. And now we use the square root property to finish completing the square. So take the square root of both sides. Don't forget about the plus or minus. All right, so x plus 5 equals plus or minus the square root of 14. We can try to simplify that, but it won't break down at all. Move the 5 to the other side, so we get negative 5 plus or minus the square root of 14. Okay, there we go. All right. So let's now go on to the next part of absolute values, which is absolute value inequalities. Okay, these guys are, I believe the young kids are saying, totes the fun. So absolute value inequalities. All right. So here are the things we need to know about absolute value inequalities. When the absolute value is less than a number, then what we get is this. We know that that expression has to be less than b, and that expression has to be greater than its opposite. Now, most of the time, the way we write this, what's really easiest for us, is that instead of writing and, which is understood to be an intersection, we just say that that expression in the absolute value, is going to be bounded by b on the right and by negative b on the left. The other statement that we have is that when the absolute value is greater than b, we're going to say that A is greater than B, or A is less than its opposite. Now remember, the word and means an intersection, where the word or means union. Okay? And just like we were saying before, all of this is going to be all well and good as long as that B value is non-negative. Okay? So we have these inequalities, which means we're going to have to deal with interval notation, which it's really not, I don't think it's that bad. Of course, it's really not that bad as long as you take the time to graph, which I do. So if we just first off start looking at the absolute value of x less than 6, there's no need to complicate it, keep it nice and small like that. Remember, the absolute value measures distance, so the distance from 0. And this guy right here says, I want your distance to be less than 6 units away. So if you think about what the graph of this looks like, here's your number line, here's 6, that's not 6, sorry, my dog is distracting me. There we go, 0. I'm trying to stream here. You have to be less than 6 units away, which basically means, like my dog sometimes has to be on a leash, so you're restricting the movement to be as far out as 6 units over here, but my dog could also go on the other side of me, which she does, and I almost trip every time. She can go out here to -6. So like, this is me, right? Here I am. My dog can go 6 units out this way, 6 units out that way, but that's it, because I'm trying to restrict her distance, restrict her movement, which is why she's on a leash. Because if she were not on a leash, she would just run away. And she did last week, but I got her. I think she just got distracted with something in the dirt, so I was able to catch up to her. So, according to what we have up here, this means that x is going to be less than 6, and x is greater than the opposite, -6. Notice the change in the direction of the inequality and the change in the signs. But really, the better way to write these intersections is to understand that x is going to be bounded by 6 on the right and by -6 on the left. Your distance has to be less than, think about me walking my dog. She can go out this way, she can go out that way, but she's going to be bounded in between those two distances. So your interval notation for this is going to be from -6 to +6. Of course, I'm using parentheses here because I'm not including either of these endpoints, right? Because this is less than and not less than or equal to. So on the flip side of this, if I say the absolute value of x is greater than or equal to 10, okay? So I've used many different examples for describing this before, but I think I've got a good one that we can all appreciate nowadays. When I have the absolute value, that means distance. And this says I want your distance to be greater, more than 10 units. That means if here I am here at 0, okay, I'm at 0, where can you be? You can be 10 units over here or further away, that's where you can be, or you can be on the left side at -10 and be further away like that. So think about with the pandemic and what's going on right now and social distancing. How close am I going to let you get to me, right? You can come as close as 10 feet, but that's it. Where can you live? 10 feet and greater, 10 feet and less than that. That's where you can be. I'm trying to maintain social distance. You stay away from me. That's what this inequality says, okay? And if you look at how this graph works out, you see that's going from -infinity to negative 10, bracket, now there's a gap. And remember, we use that union symbol to connect those guys together. And bring back 10 to infinity, like that. Now, with the statements that we had above, we would say that x is greater than or equal to 10, or the other possibility is that x is, watch this, change the direction of the inequality and change the sign. Okay? So, you are greater than 10, you're less than negative 10. That's how you can create your distance being greater. That means stay away. Social distancing. The one above, I want your distance to be less than 6. This is me walking my dog. She can go 6 feet over here, 6 feet over here, but she has to stay within that particular range. Okay? So let's apply these to some more complicated looking problems. But the concept is still going to be the same. All right. So now let's take the absolute value of 2x minus 9 is less than or equal to 23. Okay, so think about what situation this is. Is this me walking my dog on a leash, or is this social distancing and stay away? Well, the absolute value means distance, and I want your distance to be less than 23. So when it's less than, it's a restriction. You can go as far out as 23 on one side and as far out as negative 23 on the other side. So this is an and an intersection situation. We can do two separate inequalities, but knowing that it's going to be bounded in one region, we can use a single string of inequalities to express that. So 2x minus 9 is going to be less than 23, and at the same time it's going to be greater than its opposite, negative 23. And basically when you write this three-part inequality, you are creating these boundaries that you're going from negative 23 to positive 23, and you're just going to work with this three-part inequality to get x by itself. And remember, we've done these before. If I just look at this and I say solve this, you would add 9 to both sides. But since you have 3 parts to the inequality, you have to add 9 to all 3 parts. So we get negative 14 is less than or equal to 2x, which is less than or equal to 23 plus 9 is 32. And finally, that last step, to get x by itself, divide both sides by 2. We get negative 7 is less than or equal to x, which is less than or equal to 16. Now, if we are doing this the right way, the inequality has to make sense from left to right every single step of the way. Negative 23 is less than 23, right? Negative 14 is less than 32, and negative 7 is less than 16. Think about this on the number line. You are between negative 7 and 16. You are including everything in between these guys, and you are also including those endpoints, negative 7 and 16. So your interval notation is from negative 7 to 16. Right? Hopefully no big issues with that. The big thing is understanding that this is an intersection because of the direction of the inequality. So now when I write this, if I say the absolute value of x plus 6 plus 3 is greater than 20. Before we can really make a determination about what kind of inequality do we have, if it's stay close by or social distancing, we need to get the absolute value by itself. So, thank you for that. So the first thing we're going to do is move the 3 to the other side. So subtract 3. The absolute value of x plus 6 is greater than 17. The absolute value is by itself, and we say the distance is greater, which means I want to push people away. This is social distancing. I need your distance to be more than 17 units. So since we have 2 different sections, we must have 2 different inequalities. So that means that x plus 6 has to be greater than 17, or x plus 6 has to be less than negative 17. Just a moment, girl. All right, so subtract 6 on both sides here. X is greater than 11. And we do the same thing over here for this one. Subtract 6 on both sides. X is less than negative 23. When you put this together on your number line, you care about these 2 numbers. You care about negative 23 and you care about 11. So greater than 11 is open, going to the right. Less than negative 23 is open and going to the left. And you see how this makes sense. We said that the distance being greater than means social distancing. That means stay away from me. Get away. So these guys have to be going in opposite directions. And that's what I did right here. I kept this guy exactly the same, x plus 6. Greater than 17. On the flip side becomes less than its opposite, negative 17. So the interval notation is from negative infinity to negative 23 union 11 to infinity. Okay? All right, so no, you have no clue. All right, so that's where we're gonna stop things today. Thank you guys for stopping by. Hope that this has been informative. If you've missed any of the other videos in the past, there's something really easy that you can do. You can go right here. You can check them out on my YouTube channel. You can also see some of the replays on Twitch. And of course, you can follow me on Twitter for things that are not necessarily math related. Okay? So thank you guys for stopping by. Have a great weekend, and I will be in touch.